Hi everyone, I'm Trish Connor-Cato. Welcome to the Excel 2019 Visual Basic for Applications video course. This course is for beginning users looking to automate repetitive and recurring tasks in Microsoft Excel. VBA is Microsoft's programming language, and it's built into the Office applications. Our focus during this course is on Excel specifically. You'll be equipped with the basics to start writing your own VBA code, modify the code behind macros you've already recorded, and have an understanding of how VBA lends itself to creating efficiency in your daily tasks. A key component of VBA is its language elements. You'll learn about this important topic by learning about variables, their scope, and how to declare them. You'll also gain an understanding of VBA data types, intrinsic functions, and the with structure and how it provides efficiency in your code. You'll also learn to create message boxes and input boxes in this lesson, as well as gain an understanding of object variables. The next lesson will teach you how to control program flow through supported control of flow structures. This lesson begins with an overview of structures and Boolean expressions. You'll then learn how to utilize conditional branching, and the lesson ends with learning about how to use looping constructs. If you're enjoying these videos, please like and subscribe. If you want to earn certificates and digital badges, please become a member of our Patreon. The link is in our video description. If you have any questions you want answered by one of our instructors, please join our off-site community. The link is in the description as well. As always, if this course has exercise files, you'll find them in the video description below. In our fourth lesson, we're going to dive into expressions, variables, and intrinsic functions. You've already experienced comments, seen them when we fill out the description in the record macro dialog box, and we've actually modified comments and added our own comments to code that we created from scratch. And comments are known as a foundational VBA language element. Well, there are others, and we're going to get into them in this lesson. So we're going to get started by learning and understanding variables. We'll go over VBA data types and intrinsic functions, which include expressions. We saw the with structure in the first macro we recorded, the add formatting macro. It created that structure with everything that resides in the paragraph group on the home tab of the Excel ribbon. And we deleted a lot of extraneous lines just to make our code more concise. You're going to learn about the offset property, using message boxes and input boxes, and object variables. We're going to be using our regular vehicles macro-enabled file, as well as two other Excel files that are in the video description. And you should be putting these files all in the same directory. So we're going to be using an Excel file named VIN numbers and another one called sales fiscal year. Variables are often considered the most important VBA language element. Since one of VBA's main purposes is to manipulate data, variables store data in your computer's memory when procedures are executed, and the data may or may not end up on disk. Some data resides in objects like worksheet ranges. Other data is stored in variables you create. Data that is stored in a variable usually changes while your procedure executes. There are, of course, naming rules and conventions when it comes to variables, very similar to the rules and conventions, the rules for naming procedures. Variable names can be up to 255 characters, alphanumeric. The first character must be a letter, cannot use spaces or any of the characters listed on the slide. And then it has another one that is not a procedure rule. VBA is not case sensitive, but it is case preservative. So you'll learn about declaring variables in a moment, and you'll see this play out. When you declare a variable, if you declare it in proper case, right, using the rules and conventions, and then let's say the next time you reference it, you type it in all lowercase, Visual Basic Editor is going to automatically change it to the case it was when you declared it, and that's what case preservative is. A convention is used proper case for each word within the name of the variable, and we have a couple of examples. Today's date, then num. Before you can use variables, they need to be declared. And just like procedures, variables also have a scope. So there are two declaration methods. There are implicit and explicit. Implicit declaration means you declare the variable by just using it without writing a declaration statement. And this method can lead to code errors. So for example, with implicit declaration, let's say I name a variable green, for example, and then when I go to use it, I misspell green. It's going to think that I'm implicitly declaring another variable, and you can see how that could lead to coding errors. Explicit declaration is the preferred method. You write a declaration statement to officially declare the variable. Now, when it comes to variable scope, you can use either the dim or the private keyword. They mean the same thing. They're used interchangeably. They have the same result. I typically use dim, and you declare the variable at the top of the module before the first procedure. And that area at the top of the module is known as the declaration section. If you want the variable available to all procedures in a module, you would use dim or private and declare it in the declaration section. The public keyword is also used in the declaration section at the top of the module, and you use it if you want the variable available to all procedures in all modules. And then there's a static keyword. Static variables retain their value even when the procedure ends, and you declare a static variable at the procedure level. It means it's only available in that procedure. And when you declare variables, you should assign them a data type. So on this slide, it's talking about the data types that are available in VBA. And you can see the name of the data type, the number of bytes that are used, and the data type's range of values. A byte uses the data type known as a byte, uses 1 byte, and has a range of values from 0 to 255. A Boolean data type uses 2 bytes and has either true or false as its range of values. You have integer, long, single, double, currency, and then at the bottom you have decimal data type. Those are your numeric data types. They use varying bytes and they have varying ranges of values. You have a date data type. I don't think you will ever be in a situation where you're not covered as concerns a date. I mean, it goes back to the year 100 and all the way up to the year 9999. You have your string data types, fixed length and variable length, and you have a variant data type. So if you declare a variable and you don't assign it a data type, it will automatically assign it the variant data type. Look how many bytes that's using. If it's a value, it's going to use 16 bytes. And if it's a string, it's going to use 22 plus bytes. So you want to be careful and really try your hardest to assign data types when you're declaring variables. I've gone ahead and opened the VIN numbers Excel file that was in the video description, and I still have my vehicles macro enabled file open, but our focus right now is going to be on this file. So it only has one sheet, it has one VIN number, and it has several other columns: year, make, model, color, country, classification. What we're going to do is insert a new module, create a sub-procedure, and declare 6 procedure level string variables. We talked about the declaration section at the top of the module window, and anything you declare there, depending on the keyword that you're using, determines the scope of the variable. And the scope of a variable not only determines where it can be used, but also affects the circumstances in which the variable is removed from memory. Only procedure level variables that are declared using the dim keyword are removed from memory when its code has completed execution. If you use the static keyword in a variable that's declared at the procedure level, that means it's going to retain the value of the variable after it executes. So you'll see what this means and how we're going to use it when we switch over to VBE, which we're going to do right now by doing Alt F11. So I want to point out a few things to you now. Since I still, and you do too, have the vehicles file open, there's a VBA project that we've been working in this whole time for that particular file. I'm going to collapse that project. Because we have another open workbook, we have another VBA project, and it's VINnumbers.xlsx file that we just opened. One thing I want to point out, at the very top of the screen, and I'm going to just select like sheet 1 in here to get rid of the code that's on my screen. And at the very top of the screen, we have that option explicit statement. This is when it's time to learn why that's sitting there and what it means. So let's go to the Tools menu and go into options like we did earlier in the course. And one of the options under Code Settings on the Editor tab is Require Variable Declaration. And that way, we can't do an implicit declaration. We have to do an explicit declaration. The implicit ones are where you don't write a declaration statement, you just use the variable, but that's the type that can lead to code errors. So to get the system to force you to write declaration statements, you want this setting to be checked in your options, Require Variable Declaration. And that means that it produces, I'm going to just cancel out of options, it forces that option explicit statement to show at the top. So it's going to force you to do variable declaration. The other thing we talked about just a moment ago is that the scope of a variable determines not only where it can be used, but the circumstances in which the variable is removed from memory. You can always use two techniques to remove all variables from memory. One of them is the reset button on the VBE toolbar. So it looks like a stop button. When you hover over it, it says reset. And a lot of times if you get code errors, once you resolve the errors, you're going to want to reset anyway. If you ever get a runtime error, there's a dialog box that will pop up and it has an end button on it. If you click end, it will remove all variables from memory. So I've closed the immediate window as we won't be using it. It has an X in its upper right hand corner just to give me some more working space here. And what we want to do, we're going to take this in little steps. Like I said, we're going to set up the framework of a sub-procedure and we're going to declare 6 string variables. We are going to look up at the top of your screen, right underneath the option explicit statement is known as the declaration areas. That's why it says declarations over to the right in the procedure box. We are going to first insert a new module. So we're going to make sure you're on your VBA project then numbers, right? We want to be on that one. We're going to go up to Insert Module. So it gives us a Module 1, which we are currently in. And again, I always verify in the title bar up at the top what file or what project I'm in, and then what module I'm in. And this is where we're going to create a sub-procedure. We are going to type sub, and we're going to name it parse then. Since then is all capitalized, I'm going to leave it that way. Parse then. I'm going to press enter twice and press the tab key. So it gave me my parentheses and my end sub statement. I'm going to actually we don't have to press tab. I'm going to shift tab. I'm going to declare procedure level variables. But first, I want to type a comment. So I'm going to do an apostrophe and type this procedure will parse the VIN number into the appropriate columns. And then I'm going to press enter and enter again. So I have my comment line. Now we're going to use the dim keyword. So I'm going to type dim, and I want to show you two examples here. Again, you want your code to be as concise as possible. So you guys, you don't have to type or do anything other than watch my screen. I just want to show you an example here. So hopefully this example is going to show you how to make your code more concise. I'm going to highlight the lines of interest here. These variables are all using the string data type. And I typed a separate line item using the dim keyword for each item. Why would I do that if they're all the same data type? I can type this line just using the dim keyword once, separating the variable names by commas, and at the very end, giving it the as string data type. So that's the line that you're going to end up typing, and then I'm going to end up keeping. But I have another example. Let's say you were only declaring two variables and they had different data types. So in that case, you would end up with two lines. Dim dealer cost as single, dim VIN number as string. The ones that have the same data type, I grouped them together on one line. Easier to type, easier to troubleshoot. So I am going to go ahead and delete these individual rows of variable declarations, and I'm going to delete the last two, and we want to declare 6 procedure level string variables, and you're going to type this dim statement that I have on my screen. And you'll notice that when you get to the as keyword and you start typing string, a list of data types will appear. So it's not going to let you type in a data type that you just make up or pull from thin air that is not compatible with VBA. Now that we have our 6 procedure level string variables declared, and again, they're only going to be available to the procedure within which they're declared, we are going to look at building intrinsic functions. So by definition, they're functions that are provided by the application. Like a function procedure, an intrinsic function performs a specific task or calculation and returns a value. You may be familiar with the 3 functions we're going to use in this section because they're essentially Excel functions, and they're string functions in Excel. So if you've ever used any of the Excel text functions, these may be familiar to you. We're going to use left, mid, and right. So the left function extracts specified text from the left of a text string. Its syntax is left, and then you have to tell it what string expression, and then you give it a numeric expression. Don't worry about memorizing this. I will walk you through it when we're ready to go back to Visual Basic Editor. The mid function extracts specified text from the middle of a string. It has 3 arguments. Well, first you use mid, which is the name of the function, and then it has a string expression that it needs to reference, a starting position in that string, and the number of characters you want extracted. And then the right function does the opposite of the left. It extracts specified text from the right of a text string. It too has the same arguments as left. So right, and then the string expression that it's referencing, and a numeric expression that references how many characters are going to be extracted. And again, don't worry about this. I will guide you through these functions. And now I want to show you just a split screen of a slide on the right and the VIN numbers Excel sheet on the left. I mentioned earlier that these are just make-believe VIN numbers. But the way we're using them in this course and the way we're going to use them in this procedure that we're developing is based on the slide. So we're saying the first character in the VIN, so in this case, the number 1, represents the country of origin. Honestly, I don't know if that's true or not. It's just make-believe data here, but this is how we're using it. The second character of the VIN would represent the make. The third and the fourth characters would represent the model. The 11th character would represent the year. 12th character would represent the color. And the 17th character of the VIN would represent the classification. Again, I will guide you through this as we're using our left, right, and mid functions. But you have the slide for future reference if you want to kind of run through it again on your own. You'll know how we're using the VIN number. Now we're ready to use our intrinsic functions in this parse VIN procedure. We already created a blank line underneath our variable declaration dim statement in this procedure. And we're going to press tab on the keyboard to indent. And what we're going to type is range, and then in parentheses and double quotes, A2, close your double quotes, close the parentheses. We're going to use our dot notation, and now you'll see the list pop up with methods, properties, bunch of different things. We're going to start typing select, and when it shows up on the list and it's highlighted, I can stop typing and press my tab key to get it in. And I'm going to press enter. So it's going to select cell A2. And then we're going to reference one of our variables. But we're going to reference it in all lowercase. So we're just going to type VIN num and then a space bar equals, and we're going to type active cell dot, and when the list comes up, start typing value. When I see it on the list, I highlight it and tab it in. So we're saying select cell A2, and then that is the active cell once it's selected. We want the VIN number variable to be populated with whatever is in cell A2. So in Excel, you can see that the only VIN number in this file is in cell A2. So it's going to select that cell and then assign the VIN num variable that VIN number. Go ahead and press enter at the end of that line and notice that it adjusted the casing on VIN num. Remember, VBA is not case sensitive, it's case preservative. So when we declared that variable, we did uppercase V, uppercase N, and then when we typed it in, we did it in all lowercase. As soon as we press enter at the end of that line, it goes back and preserves its original declaration case. That is an example of case preservative. So now we're going to type year. So we're going in the order of the way we declared the variables. That's easy to keep yourself organized. So we started with select cell A2 and then populate the VIN num variable with the VIN number that is in cell A2. Now we're going to say what to populate the year variable with. So we type year equal, and then we're going to type the mid intrinsic function, open paren. So right underneath it, it's telling you the arguments that it's looking for. So you'll see that yellow banner there, right? Right now, it's waiting for the string argument, and then you have a numeric argument, right? And the string argument is bold because that's the one that it's waiting for. In the open parenthesis, we're going to type VIN num, the name of our variable. And again, doesn't matter how you do the casing because it's case preservative. VIN num, comma, 11, comma, 1. So the mid function has 3 arguments: the string argument, the start as long argument, right? That's the starting position. And then the last argument is the number of characters. So we're saying the year is going to equal the 11th character of the then. We're saying in that then num variable, which now holds the entire then number, we want you to go to the 11th character and extract 1 character, which is the 11th character. You're going to type a closing paren. So the 11th character of the then represents the year, and press enter. Our next one that we're going to do is the make, because we're doing them in order here. So instead of you watching me continue to type, I finished this part of this procedure. So we left off with doing the year. So I'd like you to just copy from my screen and assign values based on the character or characters in the then to make, model, color, and classification. You can pause the video until you get it done. And once you have the other variable assignments done, go ahead and compile your VBA project. So just be anywhere between sub and end sub. Make sure there's no errors. By the way, if you just watch my screen, I'm going to take out this classification line. And I just want to show you something. You don't have to worry about spacing. You know, the variable's a case preservative. So I could type that line as classification, no space, equal, mid, open paren. I'm typing then num in a weird mix of capitalization, 17, 1, and I'm not typing spaces at all. I'll type the closing parenthesis, and when I press enter, it gives me the appropriate spacing, and it case preserved the name of the variable. So you don't have to worry about your spacing. There's a line editor, so when you get to the end of the line and you press enter, it will fix little stuff like that for you. So you don't have to worry about that. Now, for the classification, since we have 17 character then, 17 characters total in the then, we could have used the write function. It would have just been write then num 17, right? The last character. But you can also use mid there. Same result. Now we're going to go ahead and I'm going to compile again since I made a change. And it's saying the variable is not defined. So I got to compile error this time. Because I misspelled classification. So it's not defined. I spelled classification and it's like, nope, sorry. You have explicit variable declaration turned on and you did not declare that variable. So I'm going to just do OK, correct my typo. I'm going to compile again. And now I don't get the error. We're going to test this at this point. So we're going to switch over to Excel. I'm going to use the Excel icon on the toolbar to switch over since I have multiple files open. And we're going to test this. We're going to go Alt F8 to open up our macros dialog box. And we'll see the macros that are in the vehicles macro enabled file that we still have open, as well as this one that's not prefaced by a file name, parse_then, because it's in the current file that we're working in. So I'm going to just click on parse_then. I double clicked it and absolutely nothing happened. I wanted to show it to you at this stage. Let's switch back over, Alt F11, and switch back over to our parse_then sub procedure. So all we've done at this point in this procedure is declare variables and use our intrinsic functions to assign each variable a value. But we haven't told it what to do with the values assigned to the variable. So nothing happened. It assigned the values to the variable, but we didn't say how to display those values. In order to tell it where to display the values of the variables on the spreadsheet, we're going to take a look at the with end with structure and the offset property And then we're going to go and complete that parse then sub-procedure. Compare these two code blocks. So the top one, these 4 lines, selection dot starts at the end of each line. It's repetitive. And then you have whatever the thing is. So selection dot horizontal alignment equals Excel center. Selection dot vertical alignment equals Excel center. Selection dot wrap text equals true. Selection dot merge cells equals false. So you're repeating the selection and the dot on every line as compared to the with, end with block of code. So you say with selection, and then you just do the dot and the thing that it is and what it equals. And at the end of it, you have an end with statement. So with, end with structure saves you some typing, makes your code a bit more concise. And that's one thing that we're going to use. And then you're going to learn how to use the offset property. It allows you to refer to a cell that is a specific number of rows and or columns away from another cell. So it has a syntax, dot offset, it is a property. And then you have the number of rows, comma, the number of columns as arguments. Both arguments are not required. If you use the rows argument only, close the parentheses after it. If you use only the columns argument, use a comma as a placeholder for the rows argument. When positive numbers are used in arguments, the property goes down rows and right across columns. When negative numbers are used in its arguments, the property goes up rows and left across columns. So I have some examples here. Range A1, so if you're in cell A1, right, dot offset 1, 2 refers to cell C2. The first argument is the rows argument. So it's saying go down 1 row and go to the right 2 columns. So if I'm in cell A1 and I go down 1 row, I'm in row 2. And if I go across 2 columns, I'm in column C. So it refers to cell C2. If I'm in cell C2 and I do an offset of -1 for the rows argument and -2 for the columns argument, it's going to go up rows because we're using negative numbers there. And it's going to go to the left of cross columns. So it's going to refer to cell A1. I have range A1 offset 1. And that refers to cell A2. I'm just using the first argument, the rows argument. So it's just going down 1 row. It's staying in the same column. No column offset. And then the last example there, range A1 offset, comma 2. So we're not using the rows argument, but we need a comma as a placeholder or we'll get an error message. And we're saying go to the right 2 columns, but stay in the same row. So that refers to cell C1. And again, this PowerPoint is in the video description for future reference. And I already gave you the typing tips that are on the bottom of the slide. So now we're going to add our with, end with structure, and included in it will be our offset statements. We're going to click at the end of the classification line and press Enter and then Tab. And we're going to type with active cell, Enter, Tab again, and type dot and the letter O. So the offset property shows at the top of the list. Notice it's a property. You can tell by the icons over time. You'll learn the different icons in the list. But the one that looks like offset, it looks like a spreadsheet or a piece of paper that a hand is holding, that indicates it's a property. If you look down at the green icon that's in the list for parse and paste special, those are methods. So just visual cues for you. Since offset is selected, I'm going to tab it in so I don't have to type. And then I'm going to do an open paren, comma, because we're not going to use the row offset, but we have to use that comma as a placeholder. We're only doing column offsets here. 1, close the paren, dot value, and you'll see value on your list, so you can double click it or tab it in, equal year. It's saying the active cell is still cell A2. Up at the very beginning, we said select that cell, and then we assigned the VIN number variable, the VIN num variable, the value of cell A2, where the actual VIN number resides. That is still our active cell. So we're saying, starting with cell A2, offset one column. So go to B2 and put in the value of the year variable, which is the 11th character of the VIN. Now, again, you don't have to watch me type. I'm going to just pause and get the rest of these offset lines in, and then you'll be able to pause your video and type them in. So after the year offset line, you're going to type the other remaining 5 offset lines on my screen for make, model, color, country, and classification. But you're also going to have to type the end with statement. Unlike when we do a sub or a function procedure, when we type sub parse VIN and press enter, it gives us the open and closing parentheses for our parameters, if any, and it gives us the end sub statement. Or if it's a function procedure, the end function statement. It will not give you the end with statement that is required with the with end with construct. So make sure you outdent and get your end with in. And you can go ahead and pause the video and get those lines typed in. And once you're done, you're going to go ahead and compile your project. Check to make sure there are no errors. And we're going to switch back over to Excel. I'm using the icon on the toolbar to get there. And so now we're ready to test it. We told it what values to assign to each variable. And now we've told it where to display those variable values, which column and cell to display it in by using our offset statements within the with end with structure. So I'm going to just be on any cell in here. And I'm going to do Alt F8 to bring up our macros dialog box. And I'm going to click on Parse VIN and then Run. Or you can double click it. And I'm like, yay, it worked. It put the right bits of data in the right cells, except for country. What happened to country? Stay tuned and we'll take a look and you'll find out. Just so you know, I did this on purpose. You can blame me, but I did it on purpose because a lot of coding is troubleshooting. And we get to debugging code in like the last chapter of the last lesson of this course. But along the way, you're going to run into situations and it's helpful to get some guidance in what to do. So in this case, everything worked except it didn't populate country in row 2. So the first thing we're going to do, since it didn't work the way it's designed to work, is we're going to delete. We're going to select B through G2 and just press delete. And we're going to switch back over to the Visual Basic editor. So the last thing we did was our with end with structure, and I'm going to start there. And I looked through the list and our offset statements, pardon my OCD, but I have them in order, 1, 2, 3, 4, 5, 6. Again, I don't want to be looking up and down if I'm troubleshooting to figure out where something is. But I do have an offset statement for country. So I'm like, okay, it's not that. The compiler did not pick up any errors. So it's something that I probably missed. So I look up in the upper half of this and I said, we're going to tackle these variables in their order. So we started with VIN num, then we went to year, make, model, color, and then we skipped country and went to classification. So we never did our country intrinsic function to tell it what value to assign to that variable, which means that it can't display anything even though we did an offset statement. I'm going to click after the color mid-function line and press enter so it's in order. The first character of the VIN represents the country. So we're going to use the left intrinsic function here. we're going to type country equals left, open paren, then num, and we want it to extract one character, which is the first character, from the left side of the then number. And we're going to close our parenthesis. We're going to press enter just so it does any formatting. And then I'm going to delete that extra line and shift tab. So classification. We're going to go ahead and compile our project again. Make sure there's no errors. And now we're going to switch back over to Excel. We're going to do Alt F8 to access our macros box. And we're going to run parse then again. And now you'll see that the year, make, model, color, country, and classification columns are filled in appropriately as a result of the parse then procedure. So because we created a sub-procedure in this file, you probably want to go ahead and save it as macro-enabled workbook. And I'm going to let you go ahead and do that on your own. And when you're done and you look in your working directory, you have two vehicles file. One is just a regular Excel file and the other is macro enabled. And now you have two then numbers. You have your regular one that we started with and then the macro enabled one that you just saved. Now we're going to begin to get some background information on both the MsgBox function and the InputBox functions in Visual Basic. So we're going to start with the MsgBox function. On the slide, it has the syntax. So in parentheses, you have a prompt, which is required, and then you have two optional arguments, buttons and title. The MsgBox function displays a pop-up box with a message for the user. Another thing, VBA will allow you to use the function without enclosing the arguments in parentheses. A best practice here is to always enclose function arguments in parentheses so you err on the side of caution and to provide consistency in your code. Now, if you do not use the title argument, the title defaults to the name of the application, which in this case is Excel, Microsoft Excel. So the table on the right tells you about the argument. It displays text in a message box for the end user. The buttons is a number that specifies which buttons and icons appear in the message box. This is optional. If it's not used, the message box will default to the OK button. And then you have the title argument. And like I said, if you don't use the title argument, it defaults to the name of the application. But if you want it to say something else in the title bar of the message box, then you would use this argument. To choose which buttons and or icons display in your message box, you do that by using what are known as VBA constants. Constants are similar to variables. They are declared. However, while variable values can change during program execution, constant values do not change. And Visual Basic for Applications constant names are preceded by lowercase vb. So you have a table on the right. We're not going to review this. Again, the slide deck is in your video description files, and you can use it for future reference. But if you just want an OK button in your message box, the value for that particular constant is 0. If you wanted a question mark icon in your message box, you would use the value of 32 to represent that. In addition to referencing the icons and the buttons in the message box by utilizing their values, as we saw in the previous slide, you can just use the VB constant name. If you say VB yes, no plus VB exclamation, it will display the yes and no buttons with the exclamation point icon. If you have VB OK cancel plus VB critical, you'll get the OK and cancel buttons and the critical warning icon. And you can also have multiple lines for the prompt argument by using the VB new line constant. So here's an example. MsgBox, that's the message box function, in parentheses, in double quotes because it's text. Do you want to continue? Question mark. Then we're using the concatenation character, the ampersand, to combine everything. And we're using the VB new line constant. So it's saying go down to the next line. And on the next line, it's going to say click yes to continue. Then after that, so all of that is the prompt argument. And then we say VB yes, no plus VB question. So we want the yes and no buttons and the question mark icon. And then the last argument is the title. And we're going to put in step 1 of 3 for a title. And when we get back into Visual Basic Editor to use the MsgBox function, you'll use the assignment operator, which is the equal sign, to assign the return value of a MsgBox button to a variable. You'll see that in a bit. And we're also going to be using the InputBox function, similar syntax to MsgBox, has 3 arguments, one of which is required, which is the prompt. It has a title argument and a default argument. And an input box is used to obtain a single piece of information from the user. The information could be a value, a text string, or even a range address. Input boxes always display OK and cancel buttons. So the prompt argument is just like the prompt argument for a message box. The title argument is the same as well. It's optional, but it's the text value that appears in the title bar. And if you don't use it, it would be the name of the application. And then the default argument is new to you here. It's the default argument for the user's input. So it's optional, but you can pre-populate it. And if the user doesn't want what you pre-populate it with, they can type over it. So we're going to get ready to use both the MsgBox and the InputBox functions. We'll be working again in our vehicles macro-enabled file. I'm in the Visual Basic Editor for our vehicles macro-enabled file. And in the Project Explorer window, I'm going to go ahead and double-click Sheet 3, New Vehicles. So this is where we use the event procedure. When the new vehicle sheet is activated, it runs the Get New Inventory calling procedure, which bundles all the other procedures to retrieve that data. And so we're going to make this further automated by modifying this procedure here. And it's going to give the end user a choice whether they want to get the new inventory or not. So we're going to modify this worksheet activate sub-procedure and click right in front of where it says get new inventory and press enter a few times. And then use your up arrow to go back up. So we want that blank line after private sub worksheet activate. Again, just for spacing purposes, and when you have to debug your code, it's easier to read. So what we're going to do is we're going to declare a variable, and it's a procedure level variable, so it'll only be available in this sub procedure. So we're going to use our dim keyword, and we're going to name the variable response, and we're going to declare it as an integer. And then I'm going to press enter. And this is how you assign the user input from a MsgBox results to a variable. Our next line is going to do just that. We're going to type response equals, remember the equal sign is the assignment operator, and then we're going to type MsgBox. We want to use our line continuation character here. We're going to do a space and then an underscore and press enter. And remember, if we didn't do that and we just press enter, we'd get an error because it's expecting the rest of the MsgBox arguments, the rest of its syntax rather, on the same line unless we tell it to continue on the next line. So that's what we've done here. And then we're going to tab again. And we're going to do an open paren, double quotes, do you want to run the get new inventory procedure, question mark, closing double quote, comma. So that's our prompt argument. and your arguments separated by commas. Now we want another line continuation, so we're going to do a space and an underscore and enter. We're ready for what combination of buttons we want in the message box, as well as which icon. So we're going to use the constant names, VB, yes, no, plus VB, question, comma. And for our title bar argument, our title argument, it's going to be in double quotes, run, get, new inventory. And I'm going to put a question mark at the end of that and close the quotes. And now we're ready to do our closing parenthesis. Now we're going to press enter. And we're going to shift tab to get back to the margin. So far we've declared a variable response as an integer. And we're saying response equals whatever the user choices are in the message box. Well, we have to tell it what to do based on a user choice. So now we're going to type if and then response equals VB yes, then, and now I'm going to use my delete key to get the get new inventory line on that same line. If the response equals yes, so if there's going to be a yes and a no button in the message box, if the response equals yes, then run the procedure. And we're not telling it what to do if they say no in the message box. So if they say no, it's not going to do anything. In other words, it's not going to run the procedure. Go ahead and compile your project. Make sure there's no errors there. And let's go ahead and save. So now we're ready to test this message box function. And I'm going to just do Alt F11 to switch back over to Excel, or any way you want to get there is fine. And we're going to click on the New Vehicles Sheet tab. And let's just say no at this point, right? So this time when we click on it, instead of just running the procedure, it gives us our message box. Let's say no on the message box, and it doesn't bring in any of the new vehicle information. Go back to your inventory sheet tab, click on new vehicles again, and now you'll see your title bar, run get new inventory. You see it has the question mark icon in the message box, and it has yes and no buttons. So we're gonna click yes this time, and it ran the procedure. And we're gonna select everything by doing Control A and pressing delete, and then just click in cell A1 on new vehicle sheet again and go back to your inventory sheet. Now we're going to switch back over to Visual Basic. We're going to use the InputBox function in our next example. So we want to, in Visual Basic Editor, we want to go to our new vehicles module. And we're going to modify this get new vehicles sub procedure. The scenario here is that it defaults to opening that received vehicles file, right? And copying and pasting the information from it. So suppose that file changes over time. Maybe this month it's called received vehicles. Maybe next month it's called something else. We want to give the users, the end user, the ability to put in what the actual file name is. Most of the time it will be received vehicles. So we're going to use that as a default setting that the user can override as necessary. So the first thing we're going to do is we're going to go ahead and update the comment line. So I'm going to just select that first comment line that says get new vehicles macro. I'm going to leave the exclamation point there though, so it will retain its status as a comment line. And I'm going to type prompts the user for the name of a file, comma, opens the file, comma, selects the data. And the second comment line, the copy and paste data, we're going to just say copy and paste data into the current workbook. So it's going to be a more accurate description than what it was before. Underneath, I'm going to press enter a couple of times. And now I'm ready to declare two procedure level variables. They're both going to be strings. So we're going to do dim file location, comma, file as string. So our two string variables. And now I'm going to click in front of workbooks.open file name and press enter a few times. And then I'm going to up arrow so I have a blank space after our variable declarations. And I'm going to type file location equals this workbook dot path, the directory path to this particular workbook, this vehicles workbook. So we're assigning that path to the variable file location. I'm going to press enter. And now we're going to say file equals, and we're going to type InputBox, open paren, double quotes. What is the name of the new vehicles file? Question mark, double quote, comma. And we want our line continuation character here, so space and underscore and enter. Now we're going to tab in one time, and now we're ready for the title argument. So that is the prompt argument. What is the name of the new vehicles file? Now we're ready for the title argument, and it's going to be in double quotes, new vehicles file name, question mark, close your quote, comma, line continuation, so your space underscore, enter. And our last argument here for input box is the default argument. So the actual text box in the input box will be populated with, and we're going to put it in double quotes, received vehicles, and you have to have the extension .xlsx, close your quotes, closing paren, enter. We're almost done with this one. And we're going to do shift tab just to get to the same margin as file location and file. And we're going to type file equals file location, the ampersand for our concatenation character, and then in double quotes, a backslash, another ampersand, and file. So we're saying that the file location is the path on your directory path to this workbook, the vehicles workbook. And the file variable is going to be the result of the user's input box choice. If they keep the default, it will be received vehicles.xlsx. If they overtype that, it'll be whatever they overtype it with. And then we're saying we want to combine the file location and the file with a backslash in between, the file location and the file name. And that is then going to be what the variable file represents. And this is assuming that the received vehicles file, or whatever file has the new inventory in it, is in the same directory path as this workbook. We have one other change to make to the existing code that was here. So I'm going to go underneath my file equal file location concatenated line, and I'm going to just delete the blank lines that are there. And now we're going to change that workbooks.open file name line. So what I'm going to do is after the equal sign at the end of that line, I'm going to type file. And then we're going to delete the continuation character. Notice how we get that red line underneath because we're not telling it to continue on the next line. And we're going to delete that whole path there because now we're saying open the file based on the variable file. So file is now the file location path, and whatever file is in, not name is in the input box, whether it's received vehicles or whether the end user types in something else. So we don't need the rest of that stuff that we had there. Go ahead and compile your project and save. So now we're going to be ready to test this. And I will say, we've given now the end user the ability to say no or yes that they want to run the get new inventory procedure. And now the additional use of being able to dictate which file to bring the data into from. I'm going to just go over to my Excel, and I'm on the inventory sheet tab. I'm going to click on new vehicles. And there's our message box, and we're going to say yes that we do want to run the get new inventory procedure. And now we see our input box. We point out the title argument, new vehicles file name, question mark, right? Here's our prompt. What is the name of the new vehicles file? And then we have our default argument where it populates it with received vehicles.xlsx, and it can be overwritten by the end user. We're going to click OK to accept the default, and it runs the procedure. And of course, we are going to select everything and delete it. Actually, go back to your inventory sheet tab. The last part of this lesson is getting used to object variables. So they're used to make your code more concise. They help you avoid typing lengthy object references. And when you're declaring object variables, the scope statements you use with regular variables are applicable. So your dim, private, public keywords are the same. Object variables are declared with object types instead of data types. So we have the syntax there. You could use dim, public, private, static, the name of the variable as the object type. So examples would be public sheet as worksheet, dim range as range. When you assign values to object variables, you have to use the set keyword. So your basic syntax would be set variable name equal object name. Set sheet equal worksheets year-to-date sales. Set range equal active sheet.range A1 through F12. Once you assign an object to an object variable, the object can be referenced by its variable name. Now we're going to do exercises, obviously, using object variables, and we're going to be using the sales fiscal year.xlsx Excel workbook in your directory. It was a file from your video description. So in this Excel file, we have multiple sheet tabs. If I just right click on your tab scrolling arrows, you'll see going from June 1st, 2016 to August 26, 2016. Each sheet is representing sales on that day. So you have your VINs, your year, make, model, classification, color, dealer costs, MSRP, selling price, and the salesperson. Each sheet has different amounts of data, so different amounts of rows of data depending on the sales on that particular date. We're going to use object variables, and we're going to create a sub-procedure that will sum the column I, the selling price column, and place the result in a cell 2 rows below the last populated cell in that column. So, for example, on the 26th of August sheet, we want the selling price sum to be 2 rows underneath the last selling price in column I. And we're going to use object variables to set that up. Let's go ahead and switch over to the Visual Basic editor and make sure you're in the right project. If you still have your vehicles file open, you may not see it here. If you don't see your file, your sales fiscal year file listed over here, sometimes you have to close the Visual Basic editor, like mine's been open the whole time. So I'm going to close it and then go back into it. Just a little trick, sometimes it doesn't refresh. And now I can see projects for sales fiscal year, which has a lot of Microsoft Excel objects because of all the sheets. I can collapse that, and I still have my vehicles project there as well. Collapse that. What we want to do in here is start this code where we're going to declare object variables. So we're going to expand our sales fiscal year project, and you can collapse your Microsoft Excel objects folder. Right-click on your sales fiscal year project in Project Explorer, hover over Insert, and choose Module. And in Module 1, we're going to start a sub-procedure. This one's not going to be very long. We can just type it in. So we're going to type sub, and we're naming it Add Totals. And I'm going to press Enter twice. And then I'm going to tab. And I'm going to declare my object variables. So we're going to use the dim keyword. And the variable name is going to be last cell as a range. So as an object, not a data type. So we're dimming last cell. We're declaring last cell as a range. Enter. And we're going to dim total formula as a string and enter. So 2 object variable declarations. I'm going to enter again and then tab. We're going to set. So we have to use the set keyword when assigning a value to an object variable. Last cell equals, and then range, and in parentheses and double quotes, we're going to type I2, so cell reference I2. Close your quotes, close your parenthesis, type the dot notation, and then end. And now when you type an open parenthesis, you'll have a list that pops up, and we're looking for the entry that says Excel down. That's an Excel constant. And we're going to close the parenthesis. So that line is saying, starting in cell I2, go all the way to the end of that column until you find the last populated cell. We're going to press enter, and we're going to type last cell dot select, right? So the last populated cell is now selected in column I. Press enter. And we're going to do active cell dot offset. You remember our offset before. In parentheses, we're going to do 2, close the parenthesis. So we're saying the last populated cell is currently selected, and we want to go down 2 rows. Dot select, and select that blank cell 2 rows down from the last populated cell. Now we have to tell it what the object variable total formula is going to be. So we're going to do total formula equals, in double quotes, equal sum, open paren, I2, colon, close your double quotes, space, and an ampersand. We'll get this one typed in and then I'll explain it. And then a space, last cell dot address, which will be on your list, open paren, false, false, closing paren, space, ampersand, and then in double quotes, a closing paren. And you're like, what? Okay, so basically, it's saying we have that last cell, right, selected. The last cell object variable is set to the last populated cell. So it's saying, give the total formula, give me the sum from cell I2 through the last cell address, wherever that last populated cell is. It could be I-24, it could be I-26, whatever it is. And then it wants to know if that last cell address is absolute, and we're saying false. It's not absolute by row, it's not absolute by column. And then we just need to enclose it in a parenthesis, a literal parenthesis. So we have that in double quotes as well. And now we just have to assign it. So we're going to go down and we're going to type active cell dot formula equals total formula. Declared 2 object variables. We set both of them. Well, last cell we said It's from I2, the last populated cell, starting in cell I2, and then select that last populated cell, offset it by 2 rows, and populate the total formula result in that cell that's 2 rows underneath the last populated cell in column I. That's what you just did. And we have our in sub statement there. And you're going to go ahead and compile your project and save. So when we get to the save part, right, it lets us know that this is a macro-free workbook. We could lose our code here. So we're going to do no on that message box. And you're going to save it, same file name as macro enabled. We are going to test this sub procedure in a different way than we've seen our procedures run before. So normally we've been running our procedures and the entire block runs. We want to see kind of like the behind the scenes, step-by-step version of what happens when we test this add totals sub procedure with our object variables. So I've arranged my windows. I have my Visual Basic editor on one side of my screen, and I have the Excel Sales Fiscal Year Now Macro Enabled workbook on the other side of my screen. So take a moment and get your screens arranged that way. And then in the Excel portion of your screen, you're going to do Alt F8 to bring up your macro dialog box. Now, I still have my vehicles file open, so you'll see the macros that are in that file, the code blocks that are in that file, but you also see our add totals code here. And so what you're going to do is you're going to just click once on add totals, and over on the right, you're going to click on step into. So now in your Visual Basic editor, you'll see that the name of the sub-procedure is highlighted in yellow, and there's a yellow arrow in the margin. So at this point, if we were running the procedure, it would be at this step. It would just be highlighting the sub-line of the procedure. There's no change in our Excel window at all. We used step into from the macro dialog box. The shortcut key for step into, once it's started, is just the F8 key on your keyboard. So now we're going to press F8. So it skipped the lines, our object variable declarations, right? It skipped those lines and it went to the first line of code. So it's saying set last cell equals range I2 end XL down. So we want the last cell to be the last populated cell in column I. But notice there's still no change on your Excel workbook at this point. Press F8 again. And now it's on the last cell select line. Again, you're not seeing any change in Excel. Let's F8 again. Now you're seeing a change in Excel. In Excel, it has now selected the last populated cell in column I. So when this active cell dot offset line is yellow highlighted, you'll see the step before it. You're now seeing the results of last cell dot select. Press F8 again. So now you're seeing the results of active cell offset by 2 rows. So now it's selected the cell 2 rows underneath the last populated cell in column I. We're going to F8 again. No change in Excel because we told it what the total formula is, right? It's the sum of from I to the last populated cell in column I. At this point, we haven't told it where to put that result. So go ahead and press F8 again, and you'll get the result now. Active cell dot formula equals the result of the total formula object variable. So you can see how this can be useful when you have varying amounts of data on different sheets, but you want the sum to be 2 rows underneath the last populated cell in a particular column. We're going to press F8 one more time to finish the procedure. So now all your yellow shading is gone in Visual Basic. And on that one sheet, the 26th of August sheet, we do have the sum of column I's selling prices. In this lesson, we did a deeper dive into foundational VBA language elements, and we started by getting an understanding of variables. And you learned that variables store data in your computer's memory when procedures are executed, and the data may or may not end up on disk. Some data resides in objects like worksheet ranges, and other data is stored in the variables that you create. And so you learned about the naming conventions when you declare variables, how to declare them. You learned about the data types that are supported in VBA and the importance of assigning data types to the variables you declare so that it uses the least amount of memory on your computer. You learned about the scope of variables, meaning where they can be accessed from, as well as two methods of declaring them, which is implicit and explicit. And we have the option explicit statement at the top of all of our modules, so it forces us to explicitly declare our variables, which is the preferred method because implicit declarations can often lead to code errors. And so we moved on to covering some intrinsic functions, and we used the left, mid, and right functions to extract data from the then string. We learned how to make our code more concise by using the with end with structure. It decreases the amount of typing that you have to do. And we did that when we used the offset property to put the extracted data into the right cells. We moved on to using the MsgBox function to give the end user more control over whether a procedure runs or not. You learned about Visual Basic constants, which are used to control which buttons display in the message box, as well as which icon displays in the message box. And then we moved on to InputBox, which gave the end user the ability to change to a different file to get that data brought into the main vehicles file. And you saw that it has similar arguments to the MsgBox function, but it also has a default argument which we populated with the name of a file, and the end user can overwrite that. And then we ended up with declaring object variables, and we did that so that we can configure a sum function on a sheet that shows two rows below the last populated cell in a particular column. And this is useful when you have sheets with varying lengths of data on it to be able to set up object variables and get the result in the same position relative to the last populated cell in a column. So lesson 5 is about controlling program executions. We're going to start by learning about control of flow structures, as well as Boolean expressions. You'll learn about conditional branching, looping constructs in this lesson as well. We're going to be using our regular vehicles macro-enabled, sales fiscal year macro-enabled files, as well as two text files in the video description. One is called Inventory Append, and the other is called Model. To this point, we've worked with code blocks, either the ones that we created via macro recordings or by writing sub and function procedures that progress line by line through the code. This is known as a sequential structure. There will be situations where a sequential structure is not what you need for your project. And we actually got to visually see a sequential structure where we did our object variables and we stepped into the code, seeing line by line how it works in the background. In VBA, you use control of flow structures in your code to make decisions such as which statements to skip, testing conditions to determine what the code should do next, and to execute some statements multiple times. You've seen a small example of that when we did our MsgBox function, where we modified that event procedure with an if-then construct. So if they did the yes button in the message box, it would run the code. If they did the no button, it would do nothing. So you've had a small example of that already. So here you're seeing the common control of flow structures. You have sequential, which we've already discussed. You have unconditional branching, and you've seen that already. You're just not aware of it yet. And that's a statement directs the flow of execution to another location in the program without condition. So when we created a calling procedure, that is unconditional branching. You're going to learn about conditional branching. The code to be executed is based on the outcome of an expression that evaluates to true or false, a Boolean expression. And that's also known as a decision structure, and it is used to implement conditional branching. And then we have our looping structure, which a block of code is executed repeatedly as long as a certain condition exists. Within the conditional branching and looping structures, there are constructs that you use to carry out the job of the structure. So we're going to focus on our conditional branching right now. We'll revisit this slide later to go over our looping structures. But within your conditional branching, there are two different constructs. There's if-then and select case. So if-then statement does something if something is true. Your select case statement does any of several things depending on something's value. And we're going to focus right now on our if-then constructs. And you also need to know a little bit about Boolean expressions here. So let's do that first. So Boolean expression evaluates to true or false. They usually contain two expressions on either side of a comparison operator. If the expression evaluates to true, the condition is met, and the structure passes control to the code to be executed. So we have an example here, sheets.count less than 3. If the count of sheets in the workbook is less than 3, the expression is true. If the sheet count is greater than or equal to 3, the expression is false. Boolean expressions are of the integer data type, so they're stored as 0 for false and -1 for true. But now we're going to just briefly go over these comparison operators. The ones that I like to know about when I tackle a new programming language is how is not equal to represented, because it varies according to a different programming language. So in here, it's less than and equal to symbols together in VBA. Also at the bottom of the slide, you use the is keyword to compare object variables, and you use the like keyword to compare string expressions in Visual Basic. Then you have the logical operators. And so you can test for more than one condition by joining Boolean expressions with a logical operator. We have the table here. We have and, or, not, and exclusive or. When you're using the and operator, each expression must evaluate to true for the entire condition to be true. When you're using or, only one of the expressions must evaluate to true for the condition to be true. The not logical operator says the expression must evaluate to false for the condition to be true. And then you have exclusive or, which returns true if the expressions are different. So I have a couple of examples of joined expressions here. Year greater than 2017 and make equals Chevrolet. Both of those conditions have to be true because it's using the and keyword in order for the expression to evaluate to true. Selling price less than or equal to 15,000 or list price greater than 15,000. Only one of those statements has to be true in order for the expression to be true because it's using the or logical operator. The if-then construct has 4 variations that can be used in Visual Basic for applications. So we've already seen if-then. If the condition evaluates to true, it executes the code after the then statement. If the condition evaluates to false, it does nothing. The next variation is if-then-end-if. It's the same as if-then, but it closes the if block with the end-if statement. And I'll just let you know now, most of the time, it needs to be closed with that end-if statement or you'll get an error. Then you have the if-then-else-end-if variation. If the condition evaluates to true, it will execute the code after the then statement. If the condition evaluates to false, it will execute the code after the else statement. This is the one that's most similar to the if function in Excel. In the if function, you give it a condition and you tell it what to do if the condition is true and what to do if the condition is false. And then we have if-then, else-if, end-if. And by the way, you can also have if-then, else-if, else, end-if. And this is used to test multiple conditions. And it can take an action on any that evaluate to true. And again, the else statement can be used if all conditions evaluate to false. So if condition is true, let's say if condition 1 is true, then it will execute the code after the then statement. Else if condition 2 is true, right? Or condition 3, condition 4, condition 5. So the ability to test multiple conditions and say what to do if any of them are true. There is another conditional branching structure which we'll talk about before we use, and that's the select case statement. But for right now, we're going to go ahead and use our if-then constructs. I'm back in the Visual Basic editor, and I'm in the code window for our Sheet 3 new vehicles. So that event procedure, which we already modified to add our if-then statement, we're actually going to put in a if-then-end-if statement in here. Imagine if there's something already populating cell A1 on your new vehicle sheet. If that's the case, if the sheet is already populated, you don't want it to have the message box asking if they want to run the get new inventory procedure because the sheet is already populated. Only if that cell is empty do we want it to bring up the message box offering the end user the choice to run the procedure. So we're going to create an if statement. And let's click at the end of our dim response as integer line and press enter. And I'm actually going to press enter twice. And then I'm going to do my tab key. And we're going to start typing this if-then-end-if construct. So I'm going to type if and then active sheet dot range and then in parentheses and double quotes A1 for cell A1. And you want to close your quotes and close your parentheses, dot value equals, and we're going to have a set of double quotes, which means it's empty. So 2 double quotes, no space in between. And then we're going to type the then keyword. If cell A1 on the new vehicle sheet is empty, then, right, we want it to do response equals message box. Do you want to run the get new inventory procedure? So all of the stuff that we have there. And now what we need to do, click after that if response equals VB yes line, press enter and tab and type end if. Now the other thing we're going to do is we're going to click in front of that if response equals VB yes line and we're going to press tab twice. We have an if construct nested within an if-then-end-if construct. It will only bring up that message box. Do you want to run the get new inventory procedure if cell A1 on new vehicles is empty? Let's go ahead and compile and then save and switch over to Excel. Go to your new vehicle sheet, say no, you don't want to run the procedure, and just type anything in cell A1. It could be number, text, anything. Now go back to your inventory sheet and back to new vehicles, and you'll notice that the message box does not pop up because cell A1 is not empty. So now you can click on cell A1 and delete that information, go back to inventory, back to new vehicles, and because the sheet is not populated, or at least cell A1 is not populated, it displays the message box, and we're going to say no on that message box. So now we're going to create a function procedure, and we're going to do it in our new vehicles module for our vehicles macro enabled file. And we're going to create a function procedure with 2 arguments. This is going to evaluate the character in the VIN that represents the model year and then mark up the cost based on whether the vehicle is from the current or previous year. So the VIN character is the 11th character in the VIN. So we're going to use an intrinsic function here within an if-then-else-end-if structure. So we're giving it something to do based on 2 different things, right? What to do if our condition is true and what to do if it's false. So the 11th character of the VIN is either populated with an A or a B. The A means it's the previous year, in which case it will get a 10% markup. The B means it's the current year, and it will get a 15% markup. So I'm going to guide you through this now. So I'm in mod new vehicles, and I did control end to get to the bottom of the module. And I'm going to type the name of the function that we're using here. So it's going to be function, and it's going to be called get MSRP. And in parentheses, we're going to give it 2 parameters, dealer cost and then num, and press enter twice. So now you'll have your function and end function statements. And this is where we're going to now set up the if construct using the mid function. So I'm going to tab and I'm going to type if mid open paren then num comma 11 1. So if the 11th character of the VIN number, close your paren, equals, and in double quotes B, then enter and tab. Get MSRP equals dealer cost times 1.15. And then we can put a comment at the end of that line. So I'm going to do a single quote, and afterwards I'm going to type vehicle is current model year, and then press enter. So only the comment portion of that line turned green. Anything after the apostrophe or single quote turns green. And it's just explaining what that math is on that line, and that the character B represents the current model year. Okay, so now we have that. We're going to do a shift tab to get back to the same margin as if, and we're going to type else, enter, tab, and we're going to type get MSRP equals dealer cost asterisk for multiplication 1.1, which is 10%. We're going to do a comment, a line comment there. So your apostrophe and then vehicle is previous model year. Enter. Shift tab, and you need to type an end if statement here. And then I'm going to press enter again, so I have that blank line between end if and end function. Now we're going to go ahead and compile and save, and we're going to call this function from another procedure. So we're not going to test it quite yet. What we're going to do is we're going to go to the upper right corner where it says get MSRP in your procedure list. we're going to do the drop down arrow there, and we're going to select the Get New Inventory procedure just to navigate to that procedure. In the Get New Inventory procedure, we're going to declare two local variables. So right underneath the comment line, at the end of the comment line, I'm going to press enter twice. And I'm going to just declare these two local variables. So we're going to dim dealer cost as single data type. And in the next line, we're going to dim VIN number as string data type. So we have our variables declared. Click at the end of the add formatting line and press enter. And you're going to type range and then in parentheses and double quotes A2 dot select. So we want it to select cell A2. And cell A2 on the inventory sheet is where the first VIN number resides. So we want that cell selected. And then we're going to assign the VIN number variable that cell as its value. So the next line down, we're going to do VIN number equals active cell dot value and enter. And now we want to assign the dealer cost value in cell G2 on that sheet to the variable dealer cost. So on this line, we're going to type dealer cost equals active cell dot offset. So we have to offset it by 6 columns, no rows. So it'll go to G2, where the first dealer cost would be. So we're going to do a comma because we're not using the row offset, and then a 6, close your paren dot value. So we're assigning the value of cell G2 to the dealer cost variable. And then we're going to call, on the next line down, we're going to call the get MSRP function and put its result in cell H2. So that line is going to be active cell dot offset in parentheses comma 7, which takes us to H2, and we're going to do dot value. So the value of cell H2 is going to equal, and this is how we call the function procedure, by its name and its parameters. Get MSRP, and then in parentheses, dealer cost, comma, VIN number. Let's go ahead and compile in our Get New Inventory and save. And we're going to switch over to Excel. So now we're going to test this Get MSRP function by initiating our calling procedure. So we're going to go to the new vehicle sheet, and we're going to say yes, that we want to run the procedure. We're going to use the default file name. And you'll notice that the MSRP column is not wide enough now, right? And that is an easy fix. So let's select everything on this sheet and delete it and switch back over to the Visual Basic editor. If you look at our Get New Inventory sub-procedure, the add formatting procedure is being called before we do the Get MSRP section of this. So we just need to move add formatting to right above the end sub statement. So I'm going to just select it and cut it. And then I'm going to click at the end of the active cell offset line, press enter, and then I'm going to Control V to paste it and get rid of the extra space by doing Shift Tab in front of it. We had add formatting in the wrong position, so now it'll add the formatting at the end after the MSRP is already calculated. And so now I'm going to compile and save again and switch back over to Excel, go back to the inventory sheet tab, back to new vehicles, yes, run the procedure, keep the default, And now you'll see that the MSRP column is populated and formatted accordingly. So the column width has been adjusted and everything. And again, it's either 10 or 15%, depending on whether the 11th character is a B or an A in the VEN. Now we can clear the sheet again, the new vehicle sheet, and we're going to create another function procedure that will get the year in the appropriate column on this sheet. We can just go back to the inventory sheet after you clear it and then switch back over to the Visual Basic Editor window. I'm still in my new vehicles module. I'm going to click at the end of the end function statement at the bottom for our get MSRP function. I'm going to press enter twice, and we're going to type function, and this one we're going to name get year, and we're going to give it one parameter, and that's going to be then num. Press enter a couple of times. In this one we want to declare a local variable. It's going to be named year marker with a string data type. So I'm going to just do dim year marker as string. We're going to set the value of the year marker variable to the 11th character of the VEN. Remember, that's the A or B, either indicates the current year or a previous year. Type in year marker equals, and then we're going to use the mid function, mid, open paren, then num, comma, 11, 1, the 11th character of the VIN number, enter. And now we're going to use an if-then-else-end if construct here as well. So I'm going to tab over, if mid, and then num, and you can copy and paste this if you want, 11, 1, equals, and then in double quotes, A, then enter, tab, get year equals 2018. And then I'm going to do a shift tab so I can get my else statement at the same margin as the if statement. So else, enter, and then tab, get year equals 2019. Enter, shift tab, and end if. And I'm going to press enter again so I get that blank line between end if and end function. Now we have to tell the get new inventory procedure where to place the result of the get year function. So in your get new inventory procedure, I'm clicking at the end of the line that starts with dealer cost. Press enter, and you're going to type active cell dot offset, and then in parentheses, comma 1, dot value equals get year, and you have to put in the argument. So it's going to be get year, we just use VIN number. And then you can go ahead and compile your get new inventory, compile get year if you haven't. It compiles everything in the module actually, so you only have to compile one. And then save. And then go ahead and switch over to Excel. Let's switch back to Excel and test our work. So at this point, we should be getting the MSRP and the year extracted from the VIN. Let's go ahead and test this. So I'm going to just go back to the new vehicles tab. I'm going to run the procedure, accept the defaults, let it click and whir, and we have our year in column B and our MSRP in column H. Again, we're going to select everything and delete it. Go back to your inventory sheet and switch back over to the Visual Basic Editor. Now we're going to create another function procedure to extract the classification from the VIN. The classification is the 17th character of the VIN, the last character of the VIN, and depending on what its numeric value is, it would either be a classification of a car, a truck, a van/minivan, or an SUV. So we're going to put that function at the bottom of our new vehicles module, and we're going to just type function get classification is what we're naming it, and we're going to give it VIN_num as a parameter. Press enter. We're going to do our function level or procedure level variable declaration. So we're going to do dim class marker is what we'll name this variable as string. Enter twice. Now we have to tell it which character of the VIN is the classification code. We're going to do that by saying class marker equals, we're going to use the right intrinsic function, and then in parentheses VIN_num, comma 1. Just extract the last character on the right of the VIN number, which is the 17th character representing the classification. Now we're ready to do an if, then, else if, end if construct, because we're going to actually be testing 4 different things. So we're going to have our test that we do on the if line, and then we're going to have 3 else if lines, so it tests 3 other things. We'll start that. I'm going to press enter twice, and then I'm going to tab. I'm going to type if class marker equals 1, then enter and tab, get classification equals, and in double quotes, car. Enter, shift tab. Now we're ready for our first of the 3 else if statements we're going to do. Else if is one word, initial capital letters on each one in Visual Basic. So else if class marker equals 2, then enter tab, get classification equals, and in double quotes, truck. Enter shift tab. Your next else if class marker equals 3, then enter tab, get classification equals, and in quotes, van/minivan. And do your last else if. So if the class marker is 4, then the classification is SUV. And you can see my else if statement for the SUV. I'm going to press enter and shift tab, and then I have to type my end if. And you want to make sure you have press enter so you get the blank line between end if and end function. Now we're going to navigate, and again I'm using the procedure list. I want to go back to get new inventory procedure. And so we've been adding these active cell offset lines to put the year and the MSRP in their correct cells, right? We have one there for dealer cost as well. And we want to make this code more concise. So we're going to create a end with block, because we have other things that we're going to be extracting as well. So it'll make this code more concise. I'm going to click at the end of the dealer cost equals line and press enter. And I'm going to type with active cell. And then on the next line down, I'm going to double click active cell before the dot offset and delete it, just leaving the dot offset. Do the same thing on the next line. Go to the end of the last dot offset line, press enter, and type end with. So now you're going to go back and click after the dot offset comma 1 line, press enter, and we can add the offset here for the classification. So we're going to do dot offset, and this one's going to be comma 4 dot value equals get classification, the name of our function, and then we're using VIN number as the argument here. So this way we have the offsets in order so far, 1, 4, and 7, and that makes it easier to troubleshoot. Now I'm going to press enter at the end of that line just to get the spacing, and then I have to delete and shift tab again. So now we have our width block set up. I'm going to select from width down to end width and press my tab key so that that width end width structure is indented. Now we can compile and save and switch over to Excel, and we're going to test this. So at this point, we should have the year, the classification, and the MSRP populate when we test this. So go ahead and switch over, start your procedure, accept the default, and now we have the year, the classification, and the MSRP extracted from the VEN. And we can switch back over to Visual Basic Editor. We've just used the if-then-else-if-end if construct, and there is a variation on that, a different construct that mimics its use, and it's called the select case in select statement. So it also tests for multiple conditions. A lot of people think that select case is easier to read than the if-then-else-if-end if construct, and also easier to troubleshoot. So the if-then-else-if-end if construct has limitations. It can only test like 7 conditions, but with select case, you're unlimited in the number of conditions that it can test. So I have a slide in here giving you the syntax, but we're going to just go ahead and use it. Before we set up our first select case construct to extract the color from the VIN number, I'm going to have you switch back over to Excel and select everything on the new vehicle sheet, delete it, and then go back to the inventory sheet, and then come back into Visual Basic Editor. I'm at the bottom of the new vehicles module underneath the get classification function, and I am going to type function, and we're going to call it get color, and we're going to use VIN-num as a parameter. Press enter twice. We're going to do a variable declaration here, so dim, we're going to name it color marker as string, and enter twice. We need to tell it which character of the VIN number represents the color, and it's the 12th character of the VIN. It's only one character, so we're going to use the mid function here. Color marker equals mid, and then in parentheses VIN-num, comma, 12, comma, 1. So extract the 12th character of the VIN number that represents the color. Gonna press enter twice and then tab. Now we're ready for our select case construct. So we're gonna type select case and then color marker. Press enter and tab. Case 0, enter tab, get color equals, and in double quotes, black. So if the 12th number of the VIN is, the 12th character of the VIN is a 0, that represents the color black. Press enter, and we're going to shift tab just till we get to the case margin, and we're going to type case 1, enter tab, get color equals white in double quotes. And press enter, shift tab. Now I'm going to fill out the rest of the cases and the rest of the select case statement, and then you'll be able to just copy it from my screen. Now you can pause the video and complete your select case statement. Don't forget the end select at the bottom if you need to make sure that that is there as well. So you have your other cases there. Go ahead and get those populated. And once you have that function, get color completed, we need to go back to the get new inventory procedure, and we need to add the appropriate offset in our width end width block for the color. And so it's an offset of 5 columns. So I'm going to click at the end of the Get Classification offset line and type another offset with a comma 5 dot value. And that one's going to equal get color, and it's using VIN number as an argument. So we have that all set up. Now we'll test the color in just a moment, but first we're going to create another function procedure, and we're not going to have to type this one from scratch because I have a text file that you're going to access that's in the video description that we'll use for this one. So in the meantime, just go ahead and compile and save. I'm going to do Control and the End key to get to the very bottom of the new vehicles module. And after that, and make sure you're after the end function statement that's down there. And you're going to go to the Insert menu and choose File. In your Files for Video Description, or whatever your working directory is where you pulled in these text files, you're going to open the text files folder, and we're going to double click the Get Model text file. So now if you look at the bottom of your screen, it brings in this whole function, and so saving you some typing here. It's using a select case statement here. I'm going to just format it a little bit. So I want a blank line after function, another blank line after the variable declaration, and then I want to have my, we're assigning it, we're telling it what numbers from the VIN number represent the model by using the mid function. So it's actually 2 characters, the 3rd and 4th characters of the VIN number represent the model. So I'm going to put an enter after the model marker equals midline. Then I'm going to select everything from select case to end select, and I'm going to tab to indent it. Now my OCD gets the better of me here. I'm also going to tab in my cases, and I can select multiple cases. So we don't have to spend time getting them indented properly and everything, but my OCD is just going crazy right now because I'm not doing that. But this is what happens when you bring it in from a text file. I'm just going to go to the bottom and put an enter in front of end function so we have that space there. And so you could see it's 2 numbers starting with the 3rd character of the VIN. If it's 16, it gives you the model as Catera. If it's 17, it's Seville, so on and so forth. And now what we have to do is we have to make reference to this in the Get New Inventory procedure so that the result is in the right cell. So I'm going to go back to Get New Inventory procedure using my procedure dropdown, and we're going to add an offset here. The offset for the model is 3 columns from the active cell. So I'm going to click at the end of my offset, comma 1 line and do dot offset. It's going to be comma 3 dot value equals get model with an argument of VIN number. And we're going to compile and save. Now we have one more that we're going to do by typing it ourselves, and then we'll test these 3. So the last one we're doing here, if you look at the very bottom of my new vehicles module, I have the framework of the function getMake already set up, and you need to copy that onto your screen, recreate that onto your screen. And then for the select case in select statement, I'm going to put up a PowerPoint slide and have you kind of work through it on your own. Get your function, your variable declaration, and the fact that the make marker represents the 2nd character of the VIN in. And once you get that in, you'll use the following PowerPoint as your guide to build your select case statement. And when you're done building it, you can go ahead and pause this video while you build your select case statement. You'll be able to see my completed block of code. And so you can see my completed getMake function. And now the only thing we have to do is get its offset reference. And by the way, the make is offset by 2 columns. And we need to put that in our getNewInventory procedure. So I'm going to switch to that procedure and put them in numerical order. So I'm clicking at the end of the offset comma 1, pressing enter. And I'm going to do offset comma 2 dot value equals get make and with an argument of then number. And now we can compile and save. And we can switch over to Excel. So we're just going to get our procedure, our calling procedure running by clicking on the tab. You know how to do this. Go ahead and yes, select the default of received vehicles. And now we should have everything extracted in row 2, the year, the make, the model, the classification, the color. Dealer cost was already there. And we have our MSRP, which is a calculation either 10% or 15% markup, depending on the year. Well done, everybody. You can clear that sheet and return to the Inventory Sheet tab. So we just used our conditional branching constructs, all variations of the if-then construct, and the select case construct. Now we're going to get into our looping constructs. We have the for to next loop, which executes a series of statements a specified number of times. We have a for each next loop, which is used on collections, and it loops through each object in the collection. And then you have your do while and do until loops. The do while loop statement does something if something else is true, and the do until loop will do something until something becomes true. We're going to get started with our do loops. So they're used to execute a block of code repeatedly. As we've been setting up our function procedures, we've been seeing that it's extracting the pertinent information from the VIN number, but it's only populating the second row, whereas we have other VIN numbers on the sheet. And so we're going to use these looping constructs to populate the rest of the sheet. Now there are 2 variations of the do loop, do while and do until. So the do while loop runs until as long as a condition is true, and do until will run when a condition becomes true. Each of your do loops have 2 different syntaxes. Both of the constructs test a conditional value, but the differences between the 2 control how they handle the tested condition. Here's the 2 different syntaxes for do while. You can start with do while and give it the condition, and if that condition is true, it will run the statement block. Or you can have it run the statement block before testing the condition, which is the second syntax there. So the first syntax will execute the statement block 0 or more times, depending on whether the condition is true. The second will execute the statement block at least once, because it's not going to test the condition until it has executed the statement block. And the same holds true for do until. You can have it execute 0 or more times by testing for the condition up front, or you can have it execute the statement block at least once because it tests the condition at the end. And then we have our for loops. So for to next and for each next. For to next executes a series of statements a specified number of times. The for each next loop is used on collections, and it will loop through each object in the collection until there are no more objects. So they do the same thing, just in a different way. So we're going to switch over to the Visual Basic editor. And what we're going to do is we're going to modify our get new inventory sub-procedure by adding a do while loop to it. The end result of this is that when we run the procedure in Excel, it is going to populate for all of the VIN numbers on the sheet. So all of the years, makes, models, color classification, all of that will be populated for all of the VIN numbers. We're going to start the modification. Look for the line in your get new inventory sub-procedure that says VIN number equals active cell value. Click at the end of that line and press enter. And we're going to indent. So I'm going to press my tab key. And we're going to do while, two separate words, VIN number, and we're going to say not equal to, so that's the less than or greater than signs together. Do while VIN number is not equal to, and we're going to put two double quotes to represent a blank. So it's going to run this loop as long as the VIN number is not empty. That's what we're saying to do there. It will stop running this loop when it finds an empty VIN number. And now what we're going to do, we're going to go down to add formatting line, click in front of it, press enter, and up arrow, and you have to give the loop keyword here. So we're going to just type loop and actually indent the word loop so it's at the same margin as do while. So it's going to run this loop as long as the VIN number not equal to empty, so not empty. And then we need to add a couple of other things here. Under our offset, comma 7 line, click at the end of that line and press enter. And we're going to do an offset of 1 row. So we're going to do dot offset and then in parentheses 1 dot select. And then underneath that, after your offset, 1 line, press enter, do shift tab, and you're going to type VIN number equals active cell dot value. So what does that do? So we have our offset, so as it's extracting things from our function procedures, it's putting them in the right cells. So after it does that, we're saying go down 1 row. So right now the active cell, right, is range A2, which we assign to the VIN number variable. So the first VIN number is in cell A2, and that's what we're assigning to the VIN number variable. And now we're saying go down 1 row. So it'll be on A3, the next VIN number, and it's assigning that cell's value to the VIN number variable. And then it will keep looping until it doesn't find any more VIN numbers. We're going to go ahead and compile and save, and we're ready to switch to Excel to test it. So start your procedure, and of course, select the default file name. And now that you can see that it populated for every VIN number on the sheet. We did that do while loop, which says continue doing this stuff, right, by extracting and putting it in the right offset columns. Continue doing this stuff until you have no more VIN numbers. And it did just that. So now the sheet is populated. We're going to perform a few more tasks in this file. And one of the things that we want to do is I have another text file with an procedure in it called inventory append. And what it will do is once you run the procedure in here and you get this sheet populated, your new vehicle sheet populated, it's going to select everything from cell A2 through H11. So it's purposely going to ignore the headings. It's going to select from A2 to H11, and it is going to cut that selection, and then it's going to paste it on the bottom of the inventory sheet. So right now, our inventory sheet goes through row 105, and anytime we bring in new vehicles, we want them appended at the bottom of the inventory sheet. So that's one thing that we're going to set up. And then the second thing that we're going to set up is we're going to write a sub procedure that will then delete the data on new vehicles. We've been deleting it manually this whole time. And then we'll add a line of code to call the procedure that deletes the data. Let's first start by deleting the data off of new vehicles, as we've been doing typically. Go back to your inventory sheet and then switch back over to the Visual Basic editor. Now we're still working in the new vehicles module. I want to get to the very bottom of that module, and this is where we're going to use a text file to get the inventory append code. So we're going to go to the Insert menu, File, and in your text files from the video description, you're going to double click Inventory Append. So when we look at that sub procedure, right, it's using an object variable, dim last cell as range, and then we have dim response as integer. And we're assigning the response to the outcome of a message box that says append the new inventory now. It will have a yes, no button, and its title bar says append inventory. If the user selects the yes button, then it's going to set the last cell to equal, starting with H2 all the way down to the last populated cell in column H, and then starting with A2. So basically, it's going to select the range A2 through H, whatever the last row in column H that's populated in. And then it's going to cut that selection, switch to the inventory worksheet, and it's going to go to the bottom. It's going to find the last populated cell in column A, and then it's going to offset by one row. So it's going to go to the first blank cell in column A and start pasting the data from the new vehicles sheet tab. And then it's just going to select cell A1 and save the workbook. That's what that is going to do. Now, we're not going to test it right now. We're going to test it in a moment. We're going to create another sub procedure. This one is short and quick, so I didn't have a text file for it. Click at the end of that in sub statement for your inventory append procedure. Press enter, and you're going to type sub clear sheet and press enter twice. So we're creating the sub procedure that's going to tell it to clear the new vehicles sheet, anything that's on it. So we're going to just do an indent here, and we're going to type worksheets. Remember how to reference from a collection, and then in quotes, new vehicles. Close your quote, close your paren, dot select. So go and select that worksheet. And then we're going to do cells dot select, which will select all of the cells on the sheet, kind of like us doing Control A. And then we're going to do selection dot clear. So clear everything in those cells. And then we're going to end with range and then parentheses and double quotes A1 dot select. We want it to end up on cell A1. So that's our clear sheet sub procedure. So we're going to call clear sheet from within inventory append. In inventory append, we're going to click in front of active workbook dot save and press enter and up arrow, and we're going to just type clear sheet to call that procedure. So we want it to clear the new vehicle sheet before the workbook is saved. And last but not least, we're going to call the inventory append sub procedure from our get new inventory procedure. So I'm going to go to my procedure drop down, make my way back to get new inventory, and we're just going to add the call line here. Click at the end of the add formatting line, which is right above in sub. Press enter, and we're going to type inventory append to call that procedure, and that procedure is going to call the clear sheet procedure. Now we're ready to compile and save and switch over to Excel. So now we're going to test to see if our append functionality works well by activating our new vehicle sheet. Go ahead and start your procedure. Use the default. It will pop up and ask you if you want to append the new inventory now. You're going to select yes. It clears the new vehicle sheet. And when you switch back over to the inventory sheet, remember we were at row 105 before, and now we're at row 115 because it appended the information from new vehicles onto this sheet. You can go ahead and save your file. We're going to be using the sales fiscal year macro-enabled file that we used earlier. And in that file, we're going to use both of the for loops. I'm going to go ahead and close this vehicles file. And I already had sales fiscal year file open. I'm going to just bring it back up and maximize it. And I'm going to actually switch over to Visual Basic Editor here and make sure that I'm seeing this project. Because again, sometimes if you have multiple files open, you switch over, it doesn't update. I want to make sure that I have the sales fiscal year project in Project Explorer. Then I go back to Excel. So this is the file earlier. We had it do a sum function and place its result 2 rows down from the last populated cell in column I. We did that earlier. Now we're going to use our for loops because we have several sheet tabs of sales data on it. And you'll see how the for each next loop and the for to next loop are similar to each other. We're going to get the same result. We're just using 2 different loops. So what we're going to do now is we're going to start with the for to next construct to repeatedly call that add totals procedure, so all the worksheets have the selling price column totaled. And I'm going to just switch over to the Visual Basic Editor for that. The Project Explorer window, I'm going to collapse Microsoft Excel objects so that I don't have all of those sheet instances showing up. So we see I'm looking at the Module 1 code window, and we see our add totals subprocedure. I'm going to click at the end of the end sub statement, and we're going to create another sub procedure. And the first time we do it, we're going to use the for to next construct. So that's when you have it run the loop a specific number of times. And we're going to create a sub procedure, and we're going to call it all totals and press enter twice. And then we're going to tab. And we're going to declare by using dim just the small letter I as an integer and press enter twice. And then I'm going to tab again. So my for loop is indented. And for this one, we're going to tell it what I equals. So we're going to say for I equals 1 to worksheets dot count. I equals 1 to however many worksheets are in the file. And we're going to press enter after that line and tab. We're going to type worksheets and then in parentheses I dot select enter add totals. Enter shift tab so you're at the same margin as your for statement, and you're going to type next I, and then enter so you have a space between it and your end sub statement. So we declared I as an integer, and I represents worksheets 1, 2, 3, 4, 5. So starting with 1, I equals 1 to the total count of worksheets in the file. We're going to select the first sheet, and once the first worksheet is selected, we're calling our add total procedure. It's going to run on that first sheet, then it's going to go to the next the next sheet, run that procedure. And it's going to keep doing that until there are no more sheets to go to. Go ahead and compile and save, and we'll switch over to Excel and test this out. So we already have this sum configured on the 26th of August sheet, and that's fine. We're going to do Alt F8 since we don't have this attached to an event procedure. And we are going to select all totals, not add totals, but all totals. That's where we put our for to next loop. So I'm going to just double click it. So at some point during the execution of the program, you will get this runtime error 1004. It says application defined or object defined error. I will explain why this happened in just a moment, but what we want to do is we want to click the end button in that error message, and it takes us to the last cell. Well, it takes us to a cell on the July 4th sheet tab. If we do Control Home, you can see that July 4th, well, it's a holiday, no sales happened on that day, and that's why we got that runtime error. So we're going to fix that by adding some code. So let's go back over to Visual Basic Editor. The issue that caused the error is in the add totals procedure, not the all totals one that's calling add totals. In the add totals procedure, we have to tell it that if cell I2, right, is blank, or if cell I2 is not equal to 0, so if it's unpopulated, if it's populated with anything other than a 0, then run the procedure. If it's not populated with anything, any number, right, then we want it to print the text no sales in cell A3. So we're going to set that up. You're going to click after your dim total formula as string line and press enter twice and then tab. And we're going to use an if statement for this. So if range and then in parentheses and double quotes I2, and we're going to use our not equal, less than, greater than symbol, 0, then if cell I2 is not equal to 0, then go ahead and run this code. Select everything from set down to active formula and tab it over. Click at the end of the active cell formula equal total formula line, press enter and shift tab. And we're going to type our else statement to go with if. Enter, and we're going to tab, and we're going to type range, and in parentheses and double quotes, A3 dot value equals, and in double quotes, no sales. Then we're going to type enter, shift tab, and end if. So your completed sub-procedure add totals should look like my screen. If the sheet is blank, essentially, right, it's going to put no sales in cell A3. If the sheet is not blank, if there are values in column I, then it's going to calculate the sum and put it 2 rows below the last populated cell in that column. That's what we just set up there. And we'll test this soon. Go ahead and compile and save. So in our all totals sub-procedure, we use the for to next loop. Now I'm going to show you the difference, and it's going to end up being the same end result between for to next and for each next. So for to next repeats specific number of times. In our example, it repeats on every worksheet in the workbook. For each next is used on collections. So the easiest way to show you this is we're going to use a for each next construct to duplicate the work that we have in the all totals procedure that we created with a for to next construct. So the first thing we're going to do is select your entire all totals sub procedure. And one of the buttons we added to the toolbar was comment block. Click on that comment block button, and it basically puts the apostrophe before each line, thereby commenting out that entire sub procedure. At the end of its end sub statement, press enter twice, and we're going to create another sub procedure named all totals. You can't have two with the same name, so that's one reason why we commented out our original one. And for this one, we're going to use the for each next loop. So we're going to just type sub all totals, enter twice. We're going to tab in and we're going to dim sheet as worksheet. We're creating like an object variable, right? Every sheet is going to be declared as a worksheet here. And now we're going to press enter twice and tab. And we're going to type for each sheet in worksheets, and that's the worksheets collection, right? So all of the worksheets in the workbook. For each sheet in worksheets, and we're going to press enter, and we're going to tab again, and we're going to type sheet.select, enter, add totals, enter, and then we're going to shift tab and type next sheet. The difference between this one and this one, first one we did that we commented out, the first one runs a definite number of times. It runs from the first sheet until it runs out of worksheets. This one, we're using the sheets as a collection object. So for each sheet in the worksheets collection, it's going to select the sheet and then it's going to call the add totals procedure. And then it's going to go to the next sheet in the collection and so on and so forth until it runs out of sheets. So after your next sheet, you should have the blank line and then your in sub statement. So since we're calling the add totals procedure, which we modified so we wouldn't get that runtime error, we'll see the results of our modification as well when we run this new all totals procedure. Go ahead and compile and save, and we're ready to switch to Excel and test this out. So I'm going to just go back. I'm going to right click on my tab scrolling arrows in the lower left corner, and I'm going to go back to the first sheet, which is 26th of August, and that's the one that we calculated the sum of the selling price before. And now I'm going to do Alt F8 to bring up the macros box, and we're going to double click all totals. And so you saw your machine kind of click and whir, right? It left me on June 1st, and we see that we have the total of the selling price, and it's 2 rows beneath the last populated cell in column I. I'm going to right click on my tab scrolling arrows and navigate to the 4th of July. And that was one sheet that caused an error before because there were no sales on that sheet. And so now you can see in cell A3 on the 4th of July sheet that it actually has no sales. So we diverted it from having that runtime error. Go ahead and save your file. In this lesson, we went over control of flow structures, and we utilized pretty much all of them. So we worked with our looping structures, we worked with our decision structures, and so we started with our just a general understanding of the structures of our control of flow structures and their variations. You learned about Boolean expressions and how to combine them with comparison and logical operators. We went into conditional branching, and that's when we used our if constructs and our select case constructs. And then we finished by using our looping constructs. We used our do loops, and then we did both variations of the for loops, the for to next structure and the for each next structure. Thank you for attending Excel 2019 Visual Basic for Applications video course.